Cool. Okay, so hi everyone. Welcome to Ethical Considerations in Data for UC Love Data Week, Day 2. Let's do some introductions. And if I can advance my slides, here we go. My name is Lee Fan. I'm the Data Science Facilitator at the UCLA Data Science Center. And I'll introduce Stephanie.
Hi, everyone. My name is Stephanie LeBeau. I'm the Data Science Librarian at UC San Diego.
I'll turn it over to Ibrahim.
Hey everyone, my name is Ibrahim Ali. I'm the Sciences Data Librarian at UCLA based in the Biomedical Library and partially at the Data Sciences Center.
And Erin.
Hi folks, I'm Erin Foster. I'm the Service Lead for the Research Data Management Program at UC Berkeley.
Cool, so this is the team. We've been working for a while, the past month or two, and we've been working together remotely to put this all together. So the first thing that we knew we wanted to tell you was that we are not the experts and that we don't have all the solutions, but this topic, ethics and data, is something that is important to all of us and that we're interested in discussing, and we want to share the information that we do have that you can consider in your work. And I'm going to go over a couple topics that we're going to cover, as well as our like outlined schedule. So the structure of this workshop is going to be a couple of presentations about these topics: data privacy, algorithmic bias, and engaging communities in research. And then after that, we're going to do some breakout room discussions. It's going to be so initially we sent out a survey asking like which topics that you would want to focus on, but we actually decided to make them more general topics so that each breakout room you can discuss any of these topics you want. And then after that, we're going to reconvene and share some discussion topics, like the highlights of each meeting. And then at the end, we'll take the feedback survey. So for this workshop, we want to use this guiding question of who is impacted by your research or work. It's something we want to take a moment for everyone to consider, and in each phase of your research, who's impacted, at what scale, whether it's individual, group, or community, and which stages. For example, when you're forming your research question, when you're doing data collection, data analysis and processing, and data publishing, who is impacted? And then from here, we're going to start off with this question and then return to that during our examples and discussion. So now I'm going to turn it to Stephanie, who's going to discuss data privacy.
So before we can even start digging into things like algorithmic bias and how communities might be impacted by your research, we want to make sure that we're all on the same page and think about why we even need to think about privacy when we're talking about data and ethics. So on the next slide, you are going to recognize a bunch of these. There have been quite a few high-profile breaches, leaks, and hacks in the past couple of years. You were probably impacted by one or more of these. I know I was impacted by these. I got emails saying, hey, your address has been leaked. No big deal. So that's not ideal, right? We're all familiar with this concept that someone has hacked in and gotten some of our personal data. But as we can see on the next slide, the impact of a breach of privacy on our personal data, it's really not equitable for everyone. So for someone living paycheck to paycheck, having their identity stolen can easily have cascading effects for years and years to come. We're talking impacts on your credit score, your ability to rent. It can absolutely have really big impacts. Vulnerable populations, like those that are transgender, may be personally at risk if they are identified in some sort of data set that identifies them as part of that population. So a lot of times that data is only available in aggregate, like this survey here. And then other certain groups like sex workers might have legal consequences to fear if they are identified. So we can think about ethics and data privacy in this context of having your data personally identified can be merely embarrassing or an inconvenience, or it can be something life-threatening. And so when we're thinking about data collection, and every data point, for the most part, is a real point that is a real person, unless you're dealing with simulations or something like that. So it is important to keep in mind that data privacy isn't just in terms of, technology and IRB and signing off on an IRB and then not thinking about it. It really is important to keep in mind. So next slide, please. So there are lots of ways to think about data privacy. So again, we're not really going to go into the terms of technological security and hardware and software. And of course, if you're using human subjects, you should be IRB compliant. We're not really going to get into the specifics of those, but really talking at this high level in an ethical context. So like there's a few things we know not to do just from basic common sense, like sharing full names or addresses, and things like that if you're sharing out your data publicly. And the thing is, those common sense precautions, the thing that you'd say, oh, I would never do that, like that would be wrong to share that. It really depends on the type of data you're used to working with. So health data obviously has more protections. It is legally more protected and it's more sensitive. But like an informal online survey where you're asking someone about their favorite cereal, it's maybe not as fraught with ethical issues because you might think there's nothing really personally identifiable there. However, as we're going to see, that may not be true. So next slide. I want to briefly mention these 3 types of privacy considerations. So again, not offering answers per se, but bringing them up as food for thought in your own research or work you do, especially in terms of this tension between openness, so being totally open and sharing and being totally transparent on the one hand, and then privacy on the other hand. So the first one I want to talk about on the next slide is personally identifiable information, or PII. You can read the full definition here. I'm not going to. Basically, it's broader than you might think. And a good example of this is IP addresses. So remember when I said, an online survey about your personal favorite cereal isn't really fraught with personal information? However, that's not necessarily true. A lot of online survey software automatically collects IP addresses, which actually is very identifiable unless you're using something like a VPN. And so really thinking through of all the information that you collect when you're doing research, even if it's something that's informal, do you really need to collect all of that? If you're using it in an analysis, like a unique identifier, could you change it to be, 1 through 7 instead of 7 IP addresses? Does it really need to carry over in its raw form? And then, of course, there's a lot of information that might not be PII by itself, but you can combine it to identify someone. So for instance, I am 31 years old. I live in San Diego, but I was born in another city in another country on a specific date. And I would bet good money that I'm the only person who fits that particular criteria of current residence, birthplace, birth date, and therefore age. So with only a couple pieces of information, it's really not that hard to identify me to an individual level. And that brings up the next slide, which is really this idea of, can data ever be truly anonymized or de-identified? So there was a study in 2019 that made big waves. It got a lot of press coverage. You might have seen it. And it basically said almost 100% of Americans can be correctly re-identified in any data set using only a handful of demographic attributes. If you're interested, there are some really great and horrifying online tools from these researchers that you can use where you put in your demographic information and it tells you what % of the time someone could correctly identify you to the individual level. I highly recommend it. You'll never sleep again. And the problem here is really one of data linking. So in the past, right, it might be pretty easy to say like, oh, I'm 31, I live in San Diego, but no one's actually going to go to this other country and get birth records and stuff. However, there's more data out there than ever before, and computing power is getting cheaper, which means it's definitely a concern that someone can feed in millions and millions and millions of data points, not have to make the connections themselves, but have a program that does it for them. And this is really of concern, especially for vulnerable groups. So maybe the location of someone in that survey of transgender Americans, their location wasn't in the original data set, but given enough variables, you could possibly combine multiple data sets to get really complete picture of that single person. And so it's not only thinking about what you are collecting, but what is it that you are collecting that can be linked to other public sources of information to really make this profile of a person. So that's really gloom and doom to start off. So the next slide is more of a what can be done about this. And the one that I want to mention, there's lots of approaches to this, right? So you can change specific values to bins. So instead of coding my age as 31, I could be somewhere, 30 to 35 range. A lot of times you might see in data people top code variables like income. So instead of saying, someone is making $150,000, they're making 100,000 plus. So that's one approach. But the approach that I want to mention is differential privacy, which is a statistical approach to maintaining privacy for small n identifiable groups. So really small groups. And this is what the census is using for the first time this year. So it's getting a lot of interest. And it basically works like this. So we have our true data, which here is school attendance by male or female. And then what we do is we have some sort of error budget, and that determines how much error we want to have in our final data as opposed to our raw data. So we draw a random point from this distribution of error and then add it to our data so that our final data set has some noise in it. So we can see here, the final table is going to say there are 2 males who never attended school, which is an underestimate. And there are going to be 12 females, which is an overestimate from the original one. It's actually quite a severe overestimate. So there are definite pros and cons to this. We don't have time to dig in super deeply because, again, we've got an hour for this whole thing. But there's a lot of information out there, and it really boils down to this tension between pure accuracy with no privacy and pure privacy with no accuracy. And this is really in the hope that there is a middle ground. And so on the next slide, which is the last slide for this data privacy section, that's what I want to have people thinking about in their own research. So what variables might need to remain confidential, what methodologies would be appropriate to preserve privacy, and really, where does your discipline and your research fall on this scale of openness versus privacy? There might be best practices if you're in, say, health or medicine, but a lot of times for domains that are just getting into this sort of big data, it's something that you're going to have to grapple with in your own work. And so when you're thinking about the scale of openness versus privacy, A, it is definitely a scale and you'll have to find your spot on it. And B, just keeping in mind that all the data that you're working with is really coming from real individual people who probably don't want to be individually identified. So that's where we're going to stop for data privacy. So then we're going to talk about algorithmic bias.
Thanks, Stephanie. One thing I want to add, building on what Stephanie has mentioned, is that while we're presenting these different topics, even if it's not directly applicable to your research, then we're hoping that these are points and issues that might bring up certain questions for you to evaluate privacy, bias, and community engagement in your own research. So in the next section, we'll be discussing considerations for algorithms and models when analyzing large-scale data. We'll cover a few examples, and by we, I mean myself and Ibrahim. While the term bias here holds many meanings, for example, in the case of statistical bias, in this context, we're referring to unjust bias, and unjust bias refers to bias that disproportionately affects certain people. I'm going to turn it over to Ibrahim now.
Cool, sounds good. In this slide, Liz, what we're looking at is some models. So while we think of algorithmic bias, I want everyone to think of how, before we start thinking about like the details of algorithms, we want to think about how researchers use models in general to better understand natural occurring phenomenon in their disciplines or just in the natural world. And on this slide, we're looking at a couple of different models. One model that maybe many of us have, or actually both probably models that many of us have looked at, for example, looking at infection rate prediction models for COVID-19 or hurricane trajectory models. And essentially what these models do from a practical perspective is help, in this case, governments or municipalities to guide decisions that they make in order to, in this case, prepare for things like a pandemic or an extreme weather event. As we move forward, and we can go on to the next slide, we can start to understand that as models get applied to more and more scenarios, they aren't always necessarily accurate. So we can imagine a scenario where a predictive model can say, this is what COVID infections are going to look like in California. But when we look at 3 individual counties, we see that the overarching trajectories of the infections for these 3 different counties can look very different from one another, and partially because any model relies on assumptions in order to create predictions. So you can generalize the population density of California, but you can't say that the population density, the way that policies are enacted, the way that people behave in Alameda versus Los Angeles County versus Trinity County are going to be the same. So that's why that's a place where models can kind of lose their legitimacy. And so there was a really great quote from Kathy O'Neill, who really points out that a model's blind spots reflects the judgments and the priorities of the creators. And we're going to see in the examples coming forward where assumptions of models led to really terrible consequences that disproportionately affected marginalized and underrepresented groups. So I'm going to hand it back to Lee, who's going to give us an overview of the 3 examples that we're going to talk about.
Thanks, Ibrahim. So following what Ibrahim mentioned regarding models, in the following examples, we're going to talk about bias in facial recognition software, algorithmic bias in health insurance financial allocation, and predicting criminality with the COMPAS recidivism algorithm. So the first example we're going to discuss is COMPAS, and recidivism is the tendency to relapse into a previous condition or behavior. And this term is most commonly used to refer to criminal behavior. So in this example, COMPAS, which stands for Correctional Offender Management Profiling for Alternative Sanctions, is a prediction model that has shown bias, and it was built by a company called Northpoint. And it's a risk assessment software that is used to identify whether or determine whether a defendant will reoffend or commit another crime, in this case within 2 years. In 2016, ProPublica obtained the risk scores assigned to more than 7,000 people in Broward County, Florida in 2013 and 14. And the reason why they didn't, or the reason why ProPublica conducted this study or tested it out was because in 2014, US Attorney General Eric Holder called for the US Sentencing Commission to study the use of these risk scores, but they ended up not doing a study. So ProPublica stepped in and did this. They found that there was a high percentage of false positives and it skewed towards Black defendants, as you can see here. I'm sorry if this chart looks a little bit small. This is from the ProPublica study. And here it says that it labeled, the algorithm labeled higher risk, labeled some people higher risk, but they ended up not reoffending. And 23.5% of those people were white and 44.9% of those were African-American. And so it definitely skewed towards Black defendants. And I'm going to read this down here. So it says, overall, Northpoint's assessment tool correctly predicts recidivism 61% of the time, but Blacks were almost twice as likely as whites to be labeled a higher risk but not actually reoffend, and makes the opposite mistake among whites. They are much more likely than Blacks to be labeled lower risk but go on to commit other crimes. So one thing, oh, I'm sorry, I'm gonna go back if I can, unless it's gonna keep going forward. All right, so another point I wanted to make about this is that one might argue that an algorithm's issues stem from the biased data, or the data that it's feeding, that is feeding the algorithm itself is biased. But in this case, historical bias plays a large part in skewing the data. And increasing the data set would not have an impact, since all the data will have bias due to the historical structure of the US criminal justice system. Now I'm going to turn it back to Ibrahim to talk about our second example.
Thanks, Lee. In this second example, so what we're starting to see is the application of, in Lee's case, a situation where they were trying to create a model, or the goal was to create like a public safety tool, but the consequence was that it disproportionately impacted a particular population. So what we're going to start seeing is this theme where the goal of something doesn't necessarily translate to the reality of its impact. And so in this case, for this health insurance model that we're talking about, a study by Obermeyer and colleagues published in Science in 2019 looked at a very popular healthcare risk prediction tool for allocating health insurance support. So the goal of the program was to provide additional financial resources for people who had significant healthcare needs. And so this health insurance group, or the algorithm, basically tried to give individual patients a risk score based on the amount of money that they spend on healthcare, with the idea being if they spend more money on healthcare, they are more sick. But as it turns out, and what the authors of the study realized, was that at any given risk score, at any given risk score, the Black population had more chronic health diseases than the white population. And it basically, the consequence, or what the authors kind of uncovered, was that because there are a lot of barriers to healthcare access, Black people end up spending less money on healthcare, despite the fact that they are, in this case, more sick. And so this healthcare algorithm incorrectly assigned these financial allocations. When the authors corrected for this error, they increased the number of Black people getting help from 17.7% to 46.5%, which is, I mean, it's really astonishing that that something that's used for health insurance for so many people can have this level of, because of a bias within the way that the algorithms were created. And critically, and one of the lessons learned from this particular study is that by factoring in, the authors, instead of, they created a new risk score based on number of chronic health conditions, and based on that score, they were able to improve the algorithm. So these things can be corrected. It's not that like it's a black box that can never be fixed. And I think that that's something that people, especially when they're teaching how to kind of create predictive models, is to really seriously think about the proxies that they use to kind of create equivalencies between what they're trying to accomplish and the information that they have available. So from here, we're going to go into another example that Lee's going to talk about using with a facial recognition algorithm.
Thanks, Ibrahim. So like Ibrahim said, in all these examples, you'll start to see a trend of these algorithms and models kind of categorizing and summarizing the data that they're using. I wanted to share an example of facial recognition and improvement in facial recognition. So there's a project called Gender Shades And this was created in 2018 by Joy Bolamwini and Timnit Gebru. You might have heard Timnit's name, Timnit Gebru, who has worked at Google's AI ethics lab. There's been a lot of political things that have come up about that, and she's left recently. So we can talk about them in the breakout rooms. But Gender Shade started out when Joy was working on her dissertation at MIT and found that the facial recognition softwares that she was testing would not be able to identify her face, and they would often misgender her. And she, and as opposed to her white, especially male colleagues. And so she constructed a data set that included politicians from 3 African countries and 3 European countries. And she tested Microsoft, Face++, which is a Chinese company, and IBM. And these were the results. They found that all of these artificial intelligence facial recognition softwares were most inaccurate or least accurate at identifying darker female photos or subjects. Overall, they found that these models, all of these models resulted in high accuracy overall, but they performed better on male than female subjects and on lighter subjects as a whole. And like I said, when they broke it down into more intersectional groups, they found a huge accuracy gap between darker skin toned subjects and male and female genders. I also want to add here that this led Joy to start the Algorithmic Justice League, and we can share information about this in our resources. Another example of folks who are trying to improve facial recognition algorithms by way of creating more representative data sets is Karkinen and Ju from, they're actually professors at UCLA. And they created a more balanced data set using over 108,000 images from the Yahoo Flickr 100 million data set, which is a Creative Commons open source data set. And they broke it down by racial groups, so white, Black, Indian, East Asian, Southeast Asian, Middle Eastern, and Latino. And they compared their data set to other commonly used data sets in facial recognition software, and it was more equally balanced. I do want to note that gender shades, the last example, they broke down the groups by skin tone rather than race. This leads me to a few other questions. This slide is actually, I just wanted to make a few points that came up about Amazon Recognition's facial recognition software. It's claimed to be able to detect emotions, but, and also in 2018, a study by the ACLU found that it matched 28 Congress members to criminal mugshots, and this disproportionately misidentified members of color. Amazon's recognition has also been sold to US Immigration and Customs Enforcement. So a lot has happened in the last year even, and I wanted to point out that in June of 2020, Amazon announced a moratorium on selling their facial recognition software following the protests and calls to justice for George Floyd. And in that same month, IBM announced that it would sunset its facial recognition products and would no longer sell it to police departments. So change in AI is happening and progress is happening, but it's taken a lot of time and change on a societal level to motivate that change. So this kind of brings us back to our guiding question: who's impacted by our research? And at the same time, maybe in regards to facial recognition, we can ask what is the right question? Like, should we be, is it right to try to find a flawless facial recognition software, or is it privacy? Because Joy Bolamwini of Gender Shades has mentioned that, or she points out that facial recognition software could be used by authoritarian governments, personal adversaries, and it really depends on in whose hands will this software be, and who is it going to impact. And I imagine that a lot of us have heard that these platforms are also being used for surveillance, and like I mentioned, in police departments. So a lot of times these are being used against people's consent, like they're not aware, as opposed to, for example, in the case of social media, when we use social media, we consent to the use of technology, and a lot of times we're consenting to facial recognition as well, through terms of service. But in the examples that Ibrahim and I mentioned before, these platforms were not, there was no terms of service for the people who were subject to these. And another thing I want to add is that the people impacted by both Compass and the health insurance risk assessment were marginalized and predominantly Black communities. So it's important to consider, following up with this question, is consent, awareness, and engagement. Are the people involved consenting? Are they aware? And to what extent are we engaging them with the process? So with that, I'm going to turn it over to Erin to tie in how we make that connection with engagement.
Awesome, thank you, Lee. So as Lee stated, it's, and as Stephanie mentioned as well in the beginning, it's easy to forget the humans when you're working at a large scale. So people become abstracted to data points, and it's often only sort of in retrospect or when we see these real world implications that we realize, these negative impacts can come to light. So in this last section, we're going to focus on bringing kind of the people back into the conversation and finish off by focusing on a couple aspects of and ways to engage communities in research. So moving to the next slide, when it comes to communities in research, there are questions related to equity, access, participation, even basic human rights that need to be considered. There are, unfortunately, I think as many of us can cite, innumerable examples across disciplines where communities have not received just treatment and have been treated more as objects of research rather than people. So in this last bit, we want to consider methods or sort of highlight different ways that studies and research groups have included the community, so have brought them in and centered them more in the research that directly impacts them. So I'll go through 3 examples, briefly touching on, one example of reporting back to study participants, one example of leveraging community expertise to better contextualize a research data set, and then the last example about working to enable broader social change and policy reform by working and partnering with the community groups. So in the first example, so this is a study that was conducted over 10 years that investigated levels of pesticide exposure in an agricultural community over, as I said, a 10-year period. So from the beginning, this study was designed to be inclusive, using an approach that may be familiar to some of you called community-based participatory research. So this is an approach that emphasizes communication and working with the given community throughout the research process to gather their input, set up mechanisms such as community advisory boards to be able to communicate with the community throughout. So in this study, the researchers were ethically committed due to the nature of this approach they're using and just driven by their own ethics to disseminate the findings, so the levels of pesticide exposure, back to those who had participated in the study. But they were challenged in how to do so in a way that would be meaningful to study participants and community members. So it's one thing to deliver the data, to disseminate it, but it's another thing to do so in a way that allows participants to be able to, do actionable things with that. So in this case, now that a study participant knows their exposure level, how might they take steps to mitigate that example? So again, leaning on the approach that they had used from the beginning, they set up a series of town halls and that existing community advisory board that I mentioned to talk about the best ways to disseminate these findings, and pass along further communication related to dealing with chronic pesticide exposure. So I include that thermometer image on this slide because it's the way that was decided to most easily and quickly communicate and memorably communicate to the study participants where they fell on sort of that scale. in terms of risk of exposure, sort of high exposure, mid exposure, low exposure. And so this was an example of, again, directly engaging with the community throughout the process, but specifically on how to best report back. And something I do want to highlight on this example is really the time and the effort that it can take to have this type of thoughtful dissemination. So despite the best intentions, the study noted that due to funding challenges, they weren't actually able to disseminate in this manner on the screen to all study participants, that they only, I think, were able to disseminate to about 40 of maybe 100 of those that they engaged with. So I feel, in this example, that it's important to note that while this, best effort was made to do this dissemination, it also ran up against friction that I think we can all understand when it comes to like funding structures and how we use our time and allocate the research time. So that's an example, specifically, again, of how to use an approach to disseminate research findings. In the next example, I want to focus more on how a case in which community members were included a little bit earlier on in the process to better contextualize research. So in this next case, I'm drawing on work and research done by the SAFE Lab at Columbia University School of Social Work. So the work of this initiative has been to investigate social media communication from gang-involved and affiliated youths that result in offline instances of community violence. So the work of this group has primarily come about, and I think in some degree is in response to the surveillance that Ibrahim and Lee mentioned earlier that can happen when it comes to social media. So the use of, for public safety reasons and efforts by police agencies and other groups to surveil the communication of certain populations in order to sort of predict when violence will occur and who has committed it. So because of the concern of this group around these surveillance tactics and concern specifically in how, without context, that surveillance method can perpetuate bias and profiling to further disadvantage certain communities. They have designed a set of studies around specifically working with Twitter data to create algorithms that hopefully more accurately identify themes that come up in certain tweets. So in this case, they work with a corpora of Twitter data that are specifically from gang affiliated or involved youth in Chicago. And they work to categorize these tweets based on certain themes. So things like aggression, things like grief or loss, and then other themes that may come up in the communication. And one issue that the study team ran into initially and pretty early on was not being able to really understand how to accurately categorize these data and tag them annotate them appropriately. So they brought in former gang members and used other community domain experts to help in annotating these tweets in order to more accurately identify these themes, with the goal of creating an algorithm that was perhaps more community informed and sort of socially conscious when it came to this. And I think a particular interesting aspect of this is the idea of broadening the role of expert when it comes to study and working with different research groups. And the last thing I want to highlight just quickly on this group is that they do have a code of ethics that they abide by, transparency at all levels, and exploring ways of documenting consent when it comes to working with social media data. And then not sharing, similar to how Lee mentioned earlier, with groups that may use this data for punitive or criminalizing methodologies. So in the last example, I want to move more broadly towards a project that works towards enacting social change. So moving from, highlighting specific concerns of a community towards transforming it to policy reform. So this is a project that some of you may be familiar with, based out of UCLA, the $1 Million Hoods Project. And it works in and around Los Angeles to shed light on the inequities and impact of mass incarceration. So this group is made up of faculty members, staff, postdocs, graduate and undergraduate students that work with local community groups, activists, and advocates to answer using data and address community concerns when it comes to mass incarceration and other types of inequity in policing. So they use publicly available data sets as well as data that they request through the California Public Records Act to address these community concerns and generate these rapid response reports, an example of which you can see on this screen, that specifically highlight the findings in a way that are easy to take away and broadly disseminate. The other aspect of, in this case, of working with the community is that they do sponsor opportunities for community members and students to collaborate more closely and gain skills in working with data. So they sponsor the Big Data for Justice Summer Institute that trains students and community members in how to use data tools, visualization, analysis tools, work with data sets, and then also gives an opportunity for these groups to work together and communicate and sort of create that pipeline of engaging, scholars and community and bringing those two closer together. So the last piece of this, and I think another reason that this group is compelling to highlight, oops, sorry, just quickly to go back, is that they've been able to use this data-driven research to influence policy reform. So specifically, the work of this group has been particularly influential in work that is being done by the Los Angeles Social Equity Program, which is working to remedy policy inequities when it comes to incarceration and other work or other policy challenges in LA and the surrounding counties. So next slide, in that to wrap up, so that was a lot. And the idea behind, giving these three, as all of the examples that have been given in our presentation, the goal is to just highlight different, and it kind of inspires us to think about different ways in which we can recognize the challenges around data privacy, algorithmic bias, and then of course, methods of engaging with a community. As you can imagine, this is not comprehensive. Topics around data governance, data sharing are highly important in this discussion, and hopefully something we can touch on. But I did want to say and end with this kind of question when we move into breakout rooms, which is, given that we know these things, given that we know these inequities exist and these challenges exist in these different areas, how do we take ownership as researchers and push this forward? How do we create this? How do we take this knowledge and then move it into action that we can incorporate in our research and really move forward on changing some of this for the better? So I will end with that and hand it back over to Lee for the breakout rooms.
Great, thanks, Erin.